folks, welcome back to the channel. Today we'll look into one of the crucial design decisions that you might have to make when working on your project. Deciding between a single-threaded event loop approach or multi-threading approach for your use case. This video is a part of our parallelism playlist where we explore different approaches for concurrency and parallelism in software systems. You might think that every problem can be solved using multi-threading, but threads are often really complex to work with. They might end up making solutions complex and debugging can become extremely difficult. Sometimes the beauty of the solution lies in its simplicity. Today we'll show that sometimes a single-threaded event loop-based approach might be more than enough for your use case. So for this video, we'll take database server as an example. This is a simple database server with in-memory key value store probably. Imagine you have this database where operations are lightning fast. We are reading from in-memory data structures and this will take mere microseconds, right? So these are really fast operations. Compared to this, network is like really slow. The operation times are in milliseconds in this case. So the round trip times could be like around 100 milliseconds. In this scenario, a single threaded event loop can be like our best friend. But why is that? When operations are much faster than the network, your thread can get free between these operations, right? So this allows us to handle multiple sockets efficiently. One thread can manage and listen if data is available on multiple sockets. This is called as multiplexing. So we'll have like a list of multiplex sockets which the thread can listen to, and whenever data is available on any of these sockets, we get notified asynchronously using some event handler or a callback. So this ensures that we can handle these requests promptly without the overhead of context switching between multiple threads. Whenever there is like a connection request, a TCP connection request on to our server, what happens is they get queued up in the listening queue. And as these operations are really fast, we get free frequently. The same single thread gets free frequently. So in 100 milliseconds, we can probably do 100 into 1000 operations. That's like 10 power 5 operations compared to the network latency that we have. So our main thread will get free frequently and it can keep listening to these sockets or accept connections. And when we accept the connection, we add it to the list of multiplexed sockets. And as the database reads are really fast, this connection gets accepted as soon as the operation that get queued up are completed. Let's look into how we'll solve the same problem using multi-threaded approach and what could the concerns be, the problems be in this case. So if we use multiple threads to solve the same problems, whenever we have a socket connection, one of the threads will accept it and access the in-memory data store and give back the response. But in this case, when there are multiple threads, reads and writes will require locks to ensure data integrity. If you lock the entire structure, what happens is other threads will not make any progress because they won't be able to access the underlying data structure as it is locked by the other thread, and will waste precious CPU cycles. To avoid this, what we can do is we can do granular locking, such as row level locking, but this adds a lot of complexity and the data structure must also support it. Implementing this might not be worthwhile. Remember, our in-memory reads are fast enough to prevent sockets in the listen queue from getting starved. So there's no need in this case to add more complexity. So adding more complexity doesn't make sense, as multithreading might lead to unpredictable bugs because of race conditions, deadlocks, and making debugging hard. And we won't get enough ROI in this case. A single-threaded event loop is more than enough for this scenario. But this approach might fail. The single-threaded event loop-based approach might fail if the database reads are really slow. If we have like a disk and we persist all our data in the disk, in this case the operations will also be in MSs, right? So if we have like multiple requests coming in, what happens is when we read from the disk, we get blocked for large amount of time as compared to in-memory reads. And this might lead to the listen queue to be overflowed, and we might lose some of the requests that are coming in. The requests will be dropped and they won't get responses. So this could lead to major issues. You might think at this point, why don't we use async reads and writes? When we do async reads and writes, at the end of the day, we offload all our operations to a thread pool, an underlying thread pool. And event loop will just call these abstract async APIs that we have provided, and they'll offload it to the thread pool again, and we'll end up implementing all this complex synchronization mechanisms and granular locking and stuff at this thread pool at the end of the day. Using async APIs that will need implementation of multi-threading in this case. Let's look into why we should opt for multi-threading when it comes to these slow operations. When reads from the database take really, really long time, in milliseconds probably, the event loop approach might fall short because of the prolonged reads can cause the listening socket queue to overflow, leading to lost connections and requests. In such case, multi-threading becomes necessary, right? For every connection we have, we can like spawn a few threads or use a thread pool in this case and keep serving these requests. Every operation can acquire row level locks. Each thread can acquire its row level lock when it's doing its operation. And this ensures that we don't block the entire system. Only people who are trying to access the same row get blocked. This allows us to handle multiple requests concurrently without overloading any single thread. So that's one of the benefits of using row level logs. In summary, the choice between a single threaded event loop and multi-threading hinges on the nature of the operations that you do. For ultra fast operations, a single threaded event loop will be more than enough. And if you have like really, really long operations or really slow operations, multi-threading with granular locks may be the way to go. Thanks for watching this. If you found this video helpful, don't forget to like, share, and subscribe. And yeah, stay tuned for more deep dives into design choices that we can take. Yeah, thank you again.